Hey guys, this is part 2 of 14A problem set. This is number 26 and 26 alone. The reaction between ethyl bromide, C2Br, C2H5Br, and hydroxide ion in ethyl alcohol is 320 Kelvin. Looks like this, you can see it. This says instead of like in aqueous solution, the ALC means alcohol. So what we're looking at is that, first of all, we got first order for each ethyl bromide and hydroxide ion. So that means that rate from my rate expression is K, and then the concentration of ethyl bromide and hydroxide ion both have ones at the top here. So a 1 and a 1, but you don't have to write those because we don't write ones in chemistry. So the question is, what's the value of the rate constant? Well, here's the rate, and here is the concentration of ethyl bromide and the concentration of hydroxide. So let's fill in. Well, first of all, let's solve for K, because we're looking for the rate constant, which means K, and K always equals rate divided by concentration of the reactants to their orders. Good. So let's fill in 1.7 times 10 to the negative 7th molarity per second divided by 0.0477 and 0.100. And those are both in concentration of molarity. Okay, so using the calculator, you guys can do that. You can figure out, please, if you're listening to the screencast, obviously you are, I want you to do that math and do that. So let's take a look at what the units would be, though. What would the units be? So I do want you to find the value. I don't want you to leave that blank, or I'm going to mark points off. So whatever you get here, that's what I want to see. Now let's take a look at the units. I got molarity here, and one of the molarities is on top. So I know I'm going to cancel one of these with one of these, and that leaves me with molarity minus 1, seconds minus 1. Those are the units. That would be the answer to B. And you're going to find the answer to A. All right, let's scroll down and take a look. How would the rate of disappearance of ethyl bromide change if the solution were diluted by adding equal volume of pure methyl alcohol? I don't know what happened here, so we're going to just ignore. We're just going to ignore this stuff here. So it says, how would the rate of disappearance change? Well, if we add equal volume, that means that we double the volume of the solution, which means that we would have, let's take a look at it like this. Like that. I would divide each one of these in half, and because I'm dividing each one of those in half, that means the rate would actually be divided by fourths, because it's this times it's the 1/2 times the 1/2 equals 1/4 for the rate. Yeah, 1/4. Okay, that's it for this problem. Stay tuned for part 3.